Thanks everyone for joining me today. Uh, this building is really awesome in person, but given the situation we're in, I think this will hopefully give you a good feel for the structure. I have lots of pictures from different angles, and hopefully this is a good substitute for our tour and a really cool thing to look at. So first off, my name is Jonathan Brower. I'm a structural engineer at LA Feast Partners in Dallas, Texas. I've been at LA Feast Partners for a little over 8 years now. I went to A&M and got my bachelor's and master's degree in civil engineering from there, and started working right out of school at LA Feast, and really loved every minute of it. And this project has by far been my favorite project that I've gotten to work on so far at LA Feast, and it's got lots of unique challenges, and it's a really impressive structure, and I'm excited to share it with you all today. First off, I wanted to pull back the curtain a little bit more on myself. One of my favorite things about ASCE is the people and all the interaction you get to have at events like CECON. And so I miss the in-person side of it and the kind of after hours networking that happens and getting to know more about people. So I wanted to share just a little bit more about me for those of you who don't know me. So I grew up in far west Texas in El Paso, right there on the New Mexico border. So that bottom left picture is a photo of me up in the mountains right behind the house I grew up in El Paso. So that was like a 30-minute walk from my backyard, and it was really awesome growing up in El Paso. It's right on the border. I went to a high school where literally half the class would cross the border every day from Mexico to come to school. So it was a really unique environment for me to grow up in. I thought there was so many normal things about it, but now that I've been away from El Paso for so long, I realize how unique and special a place El Paso is, and I think it really shaped a lot of who I am today. Like I mentioned earlier, I went to A&M after I graduated high school in El Paso, and I played club tennis there. Tennis was the sport I grew up playing pretty much since I was a little kid. And I got the opportunity to play even through college. I wasn't on the varsity team, but playing club tennis was a lot of fun. Got to travel over the state and play other schools. And then, like I mentioned, I started working at LA Feast Partners right out of school, and have been there for a little over 8 years. And that's a photo of me actually on this job site on the level 4 superstructure that we're going to talk about here. And then ASCE has been a part of this whole story the whole time. When I was at A&M, I got involved with the student chapter there. And then as soon as I moved to Dallas, I emailed the Dallas branch and asked them how I could help out. And Sean Merrill, our new Texas section president, was actually the Dallas branch president at the time. And he said, sure, you can help out with membership. And so I started helping out that year, managing our membership database. And now I'm actually the Dallas branch president, and really excited to be going into this new ASCE year, even though we're all on this remote format right now. That's my wife, Lindsay, on the right. She's also a structural engineer. She does not practice engineering anymore, though. She actually just in the past year switched over to working for an owner's rep firm. So she actually helps building owners manage their construction projects and manage all their consultants. And her company actually has been the owner's rep on a few projects that my company works on. So she can critique my work while we're at the dinner table, since she knows all the ins and outs of structural engineering. And that's our little boy, Noah. He just turned 6 months old this past Sunday, and he's really the best part of 2020 so far. He brings a lot of joy to our lives, and he's a lot of fun to be around, and I can't wait for him to get home later tonight from daycare. I really enjoy running. Running is my big passion outside of the work I do and ASCE. I enjoy waking up early in the morning, getting those runs done. I'm also a big Dallas Stars fan, so watching the Stars make that run to the Stanley Cup final this year was a lot of fun. Noah, he got woken up a few times by me yelling at the TV whenever they kept winning, so I'm sure he's in for a long ride with that too. So now I'll hop in and just give a little background on LA Feast Partners and who we are and what we do. So we are a building structural engineering firm. We don't do any heavy civil structures. We don't do any bridges. We are primarily focused on building design. We were founded back in 1979 by a gentleman named Larry Feast, who was a graduate at the University of Texas at Austin. He actually had worked at a couple other structural engineering firms here in Dallas and risen all the way up to the point of being president, actually, of Datum Engineering, and saw that company losing some engineers and really kind of not being able to give his engineers the growth that they needed and that he wanted to give them. And so he decided to go out and start his own company. So he, in 1979, opened up his firm, Larry Feast Engineering, with just it was just him and a draftsman, and they were working out of a house in the Lakewood area of Dallas. And now we've grown to the point where we have just under 100 employees split between our Dallas and Boston offices, about 45 licensed engineers, and then 35 EITs, and a BIM department that's growing slowly as we start to expand into our the VDC sector of the market and helping out general contractors through the construction process. Some big projects that you might have heard of that we've worked on of DFW Terminal D. So if you've ever taken an international flight out of the state of Texas, you probably have gone through that Terminal D facility. We worked on Liberty Mutual Plano headquarters up there at 121 in the tollway. Museum Tower is the first high-rise we did in downtown Dallas, right there next to Clyde Warren Park. And then Moody Performance Hall is a beautiful facility in downtown Dallas as well that we completed, I believe, in the last decade. So some of the market sectors that we are in, it's pretty much everything except for major sports stadiums. So aviation, big component. Like I mentioned, DFW Terminal D earlier. We're also involved in the Love Field Modernization Program, and this is a terminal at the Sacramento Airport in California. K through 12 education is one of our biggest sectors. Actually, the majority of our billings actually come from K through 12 projects. This is a beautiful CTE center by Corrigan Architects up in Garland. We do municipal work as well. This is a project I actually got to work on. Lots of fancy stone and brick detailing on this one. This is a municipal center for North Richland Hills, and their city council chambers are located within this facility, as well as a police station, admin offices, and everything that the city needs to function. Mixed use is kind of where I got my start at LA Feast Partners. I worked on a lot of mixed use projects, and I worked on Legacy West. This is kind of the last big one that I did. This is up at 121 and the Dallas North Tollway in Plano. It's a really big, sprawling mixed use development that has apartments and restaurants and shops and offices and tons of garages. I worked on, I think, 5 or 6 different garages out on this site. Commercial office is a big component also of our work. I'm going to talk about another big commercial office later on, but this is the Toyota North American headquarters. I'm also up at that DNT 121 intersection here in the DFW area. We do a lot of mission critical work as well. This is a cool component, I think, of our kind of project portfolio. You know, I mentioned a lot of projects that are really big and highly publicized and in the newspapers and that you can talk all about, but we also do a lot of work that is top secret that we can't disclose where the projects are located or who the client is. And these are data centers. So these are facilities that contain lots of sensitive information and important information, and they cannot go offline in case there's a major natural disaster like a big earthquake or a tornado. These are hardened buildings that are designed to sustain these major events. We also work on religious facilities. This is a great example of a synagogue up in Buffalo, New York. It's actually done by our Boston office. Great example of exposed structure with these glue lam structural elements. Our Boston office also does a lot of conversion and rehab work. So for you gun enthusiasts, this is actually the Winchester, the old Winchester ammo factory in New Haven, Connecticut. And the building had been abandoned for decades, actually, and we came in there and brought it all back up to code. And now it's some office space and a lot of apartments. Multifamily is another thing that we do here in Dallas, but primarily we do a lot of work up in the Boston area. That's designing either steel or concrete podium slabs for multifamily wood structures to go on top of. Do a lot of healthcare work. Also, this is a a great example of a hospital that doesn't look like a hospital. And this is over in Fort Worth, Texas Health Clear Fork. Just, yeah, beautiful building, looks really nice, all lit up at night. And just recently, we've gotten into the high-rise market, especially here in Dallas in the Harwood district, which is the area right next to the American Airlines Center. So this is one of the first towers we did over in that area, and this is Blue Seal. It's a 33-story residential building. If you look really closely on the top level here, there's actually 2 swimming pools that cantilever out past the face of the building. You can look, and they have glass bottoms, and you look straight down all the way down the face of the building. And I think these are actually 2 penthouses that are still available. So then if you have an extra, I think 25 or 30 million laying around, there's an address for you here in the Harwood district of Dallas. I also wanted to touch on some of the specialty structures we work on, because the structure I'm going to talk about later today is really unique and special, but there's other things we've also kind of gotten into. And going along with K through 12 design, a lot of those projects now involve storm shelters. So these are hardened buildings, again, that are designed to withstand varying degrees of tornado force winds. And so these require a lot of unique detailing and extra beyond code level design to ensure that these buildings don't collapse in the event of a tornado. Blast design is another thing we've gotten into, especially out there at Terminal D. Fascinating story that was before my time at LA Feast Partners, but Terminal D, the structural construction documents were issued, sealed and issued for construction. They actually started drilling the piers out there on Terminal D. And then September 11th happened. The attacks on September 11th happened, and construction completely shut down. And they had to reevaluate what would need to be done within the terminal from an architectural standpoint in terms of new security features, and then also how they were going to take into account designing the exterior and the car side, basically part of the terminal, for any blast considerations if there was a terrorist attack in this area. So they had to go back, completely redesign a lot of the structure for some blast loads that were given to them by another consulting engineer. And so I thought that was a fascinating story about Terminal D. Do a lot of monumental stairs also in these buildings. Once they get inside and they want to have a really nice exposed staircase, this is an example of what I call our birdcage stair up at a private school in Massachusetts. And that entire stair all hangs from that one point up there at the top of the stair. That's a beautiful stair. We also, I said we don't do bridges, but we do occasionally get involved with pedestrian bridges when they involve our buildings. So this is the Southwest Airlines headquarters building that actually has 2 facilities that are on either side of Denton Road in Dallas. And so they need a pedestrian bridge to connect those 2 facilities that goes over a set of dart tracks and over Denton Road. And so we designed this pedestrian bridge and designed some bridge bents, which is something we don't usually get into, but that's a unique example. So now I'm gonna hop into the main project that y'all have all been promised today. And if you have questions at any point, you can unmute yourself, ask a question, be happy to answer it. So I'm just gonna get rolling here. And yeah, by all means, interrupt me if you want me to explain something a little bit more in depth. So this is the Baylor Scott and White Admin Center. It's in the Deep Ellum area of Dallas. This is an architectural rendering that was made before design even began. This is kind of in the schematic design phase. And so I put this up here so that y'all can see the completed photos I have at the end and see just how close we got to this rendering. And for those of you that don't know, Baylor Scott and White is a major healthcare system here in Texas. They had a lot of offices kind of scattered throughout the Dallas area, and they wanted to create a localized central location for all of those admin to work in. And so that's what brought about this facility. So it is not a healthcare facility. It is in an office, corporate office building, and a parking garage as well. So let's just summarize the project team. The core and shell architect was Perkins and Will. Perkins and Will is a very design-oriented architecture firm. They're always pushing the envelope They're always challenging their engineers to come up with designs that are, sleek and slim, and so really pushing the boundaries of things. And so it's always a lot of fun to work with them because they really do push us, and they produce beautiful buildings. Interiors was done by Corrigan Architects. They're another big architecture firm. Civil engineer was RLG. MEP was done by Telios. The geotech was ECS, and of course, LA Peace Partners, we were the structural engineer. So a little bit about the building itself. They called this, the design architect, he liked to call this a ground scraper. And so basically this building is equivalent to 10 typical office floors that have been compressed and spread out onto 2 floor plates. So there's 2 main floor plates in this building that make up about 300,000 square feet of office space to hold 1,000 employees. And below those 2 floor plates on the south side here on the right of your screen is a 5-level parking garage that's 375,000 square feet of parking that has 1,000 spaces for all those employees that are working inside this facility. Some of the major milestones and just basic facts about the building. The total project cost was $70 million. We began design in early 2018. I think I first started doing some engineering calcs and creating some models in around March of 2018. We issued an early foundation package and the began construction in October of 2018. It was structurally topped out last summer. And then just about, I would say maybe a month and a half ago, they started having employees working in there. I think they're at about 50% capacity right now. So this is a look first at our structural Revit model. So we use Revit to coordinate with the MEP engineer and with the architect. So that allows us to overlay our models and coordinate where our columns are, making sure that we have everything hidden in the architect's soffit, that we understand where they have exposed structure, all of that. This is a picture of our structural model, though, with the architecture unloaded. So you just get to see the skeleton of the building. This is a look from the other side of the other corner of the building. You get a good view of the parking decks and then the 2 big floor plates that make up that 300,000 square feet of office space. So today, though, I really want to focus on what I'm going to call area A and B, which is this kind of trapezoidal shaped part of the building that you see on the bottom left of your screen. So what makes this part of the building really unique is that the first, we do have some occupied space you can see in the middle of the building on level 1 and level 2 and level 3, but the majority of the occupied space is up here on level 4. And level 4 is 50 feet in the air, 50 feet above our pier caps. So we had a really unique challenge here in that we needed to have these super tall columns, and there was an extra layer of complication added when the architect wanted to remove basically more than half of the columns. So I'm going to explain that next. This is a look at the typical floor plate at the roof and level 5. So the two levels above level 4. This was a pretty typical 8-inch thick 2-way PT slab on 24-inch diameter columns. There was no drop caps or drop panels. We had shear stud rails in the slab so that we could eliminate those drop panels and caps. The grid spacing was 30 foot by 30 foot, which is pretty typical for an office. So this was, pretty, for the most part, simple PT slab design. For those of you that may not know what PT is, that's post-tensioning. So those are cables that are laid out in the slab. And after the concrete is poured and has reached a specified strength, they will pull those tendons and pre-compress our concrete slab. And kind of the simplest way that I can describe it is you can imagine tying a rope to a tree, and then you kind of lean back and pull on that rope. And then you get your friend to come along and jump up on that rope, and they might start to sag a little bit, right? And so you need to pull a little bit harder, but you can only pull so hard so that you bring 3 of your other 3 friends over and they all start to pull on that rope. And as all of you pull together, you're able to put more force in that rope and kind of help lift your friend up as they're balancing on the rope that you've tied to the tree. So that's what post-tensioning does. We're trying to balance out the loads that are on our structure, and it allows us to create a structure that is much thinner than you would ordinarily need without post-tensioning. So, like I said, this is the quote unquote easy part. All those pink dots are the typical 24-inch diameter columns on a 30 by 30 grid. But when you get down to level 4, this is what one of the engineers in our office deemed the super floor. The architect wanted to eliminate every other column in both directions. So you can look closely and still see little pink dots. Those are the columns above that go up to the roof level. And then in neon green, I tried to highlight the columns that go down to the foundation. So only the columns that are in green here go down to the foundation. All the other spots where you see pink dots, we had to somehow resolve all of those column reactions. And the way that we did that is we created this network of 3 foot wide by 5 foot deep transfer girders. So that's what I have outlined in blue here. It kind of creates this waffle slab looking kind of structure. And these are PT girders that are acting in a two-way fashion so that we can transfer all of these column reactions out to our big green columns that actually are going down to the foundation level. So I'll zoom in a little bit here on the pointy corner so you can get a better idea of what's going on. We did have to do some cantilevering out here to pick up this diagonal edge. This was a really tricky part of the design. I used a program called RAM Concept to model and design this post-tension floor system. RAM Concept is pretty commonly used when it comes to two-way slab design, and I was able to kind of use the power of Concept to create this unique two-way girder system. And so yeah, when we eliminate every other pink column in the other direction, we go from a typical 30 foot by 30 foot grid to a 60 foot by 60 foot grid. So yeah, these green columns are basically all at 60 foot on center. So construction began, and I got to go out there and start looking at stuff. And this is a look at the formwork on these transfer girders before they started dropping in some rebar cages. These red tendons you see, those are the post-tensioning tendons. So it's really remarkable to see this formwork out there. And went out there the next week. This is that exact same corner of the building. They've got the rebar cages in there, and if you look closely on this bottom left, you can see there's a guy down in there working to lay out the reinforcing and make sure that we've got everything oriented correctly. And so it was remarkable to me to go out there and see this transfer girder that's big enough to fit a person. This is another look down that same girder. You can see there's another guy now squatting down in there trying to make sure all of our stirrups are in the right location, and also making sure that those PT tendons get slipped into their anchorage locations properly. This picture on the left is me kind of sticking my hand and the camera down into the rebar cage, and you get a good look at all those PT tendons that are in these transfer girders. So again, those red tendons, those are the rope that I described that you attach the other end to a tree, and you're trying to pull and balance up your friend who's trying to slackline on the rope. That's what these tendons are doing. We're trying to counterbalance all of the floor load and column reactions that are coming down from above. And again, just another really cool photo there on the right of the whole construction site as they started to go above level 4 in area C and D. Here's a look at that same corner with the majority of the reinforcing and post-tensioning cables laid out. Get a nice view of downtown Dallas there on the back left, and then Baylor Hospital there on the right. So this was pretty much the day before they poured the concrete on this first part of the superfloor. So a few weeks went by, and they got the concrete cured. They pulled all the post-tensioning cables. I reviewed every single tendon pull, made sure that it was to our specified force, and then they got to remove all the shoring and formwork. And this was the end result. It was really amazing to go out there and stand underneath all of this and see kind of everything that I've been working on for months come to fruition. the architect didn't like the waffle slab look as much as I did, so all of this actually got covered up with a soffit. So when you go out there now, you won't see this this waffle slab looking thing anymore. It's all covered up. So I made sure to go out there as much as I could before they covered that all up and get lots of photos, and that's what I'm going to show you all now. So here's a couple more photos walking underneath the superfloor. Austin Commercial was the general contractor on this. This is my friend Chris. He was one of the superintendents out there on the site, so he would always walk me around. It was really fun to learn from him and kind of get feedback on our design and our details, and talk about ways we could do it better the next time. There's a really good look at that pointy corner and the massive blade columns that we have going up. And again, it's just really impressive to stand under here and see these really big columns and these long spans supporting all of this structure above. This is a perspective from level 3. So I mentioned that there is some occupied space below the superstructure, and so that is just some office space, and there's actually a small conference center that Baylor Scott and White uses. But I thought this was a really cool photo, looking at that network of transfer girders. Here's a view standing on the northwest corner of the building. It's a panoramic shot, so the building is not curved like that. That's just kind of the effect that my camera had when I was taking a pano photo. But there you see the parking garage on the far right, and you can see that at this point in construction, they were starting to put the facade up on the building. If you zoom in a little bit and come underneath that pointy corner, again, you can see the underside of the structure, and you get a little feel for the scale and the massiveness of this space. There's some workers down here, and you see them next to these really big columns. There was some form work that didn't quite come off the concrete very nicely, so it's hanging out there. So they had to bring out these scissor lifts and get some people up there to pull these forms down. Another really good look at the pointy corner of the building once all the forms had come down. It turned out really nice. We didn't have a lot of consolidation issues with the concrete. We kind of got this nice clean bottom of beam surface, even though we had this really deep 5-foot structural beam. Again, I just love this pointy corner. I was taking lots of photos of it. There's this old water tower over here, so I thought this was a really cool photo, just seeing the perspective of this massive column next to this kind of spindly water tower here on the left. This pointy corner, in addition to this massive, cantilever transfer beam that I had to design, it was also kind of finicky designing the points of this slab. So, relatively speaking, designing slab to cantilever out like that is pretty simple, but we wanted to be really careful that none of this concrete would spall off later on. So I spent a lot of time drawing details and getting some supplemental reinforcing in these pointy corners so that they stayed pointy corners and you didn't get concrete that was chipping off in the wrong place. And it looks really cool when you look at it from below. And the outer plane of these 3 slabs is actually different. The bottom level sticks out the most, and the glazing sits on level 4. It bypasses level 5, and then it actually frames directly into the underside of the roof. So here, next are my 2 favorite photos from the whole project, and I think this perfectly illustrates kind of the structural engineering magic that we had to have happen on this project. So there you see a column coming down from the structure above, supporting the roof slab and level 5 slab, comes down, hits level 4, and then it just disappears. So you have nothing there, and you get a good look at our 5-foot deep PT transfer girders that are carrying all of that load out to our big blade columns. Here's another good look at a column by an opening, so you get a good view of that transfer happening. I remember this was at the topping out party, and I was walking around the building with the geotech, and he asked me if that was supposed to be like that, and I pretended to freak out and be scared for a second that they forgot a column, and then I could tell him now that I meant to do that the whole time. So it's a lot of fun to show people these photos, because I think it just perfectly illustrates what's happening here at these transfer conditions. We had another unique transfer condition in area C of this building. So the entire time I've been talking right now, I've been talking about area A and B. This right here, you can see we have double columns, and there's a little joint between them. That's our expansion joint. So everything to the right is area A and B, what I've already been talking about. Everything to the left is area C and the parking garage below. Right when you get to area C, there's actually a road right here. So this is Race Street. It was an existing road, and it's still there now. So the building kind of straddles this road, and so that actually required some of the longest transfers we have on this job. So those other transfer girders in area A and B, it was a network of two-way transfer girders that were spanning 60 feet on center. This is actually a 65-foot transfer span. So it's actually longer than area A and B. So you can see, if you look closely right here, kind of in the middle of this transfer girder, you can see the column coming down. And there's a set of those columns at all 5 of these transfer girders. And it's kind of hidden behind this piece of facade, but there's another set of columns that actually also gets carried by these transfer girders. Now, the other unique part about this EJ and the location of these transfer girders is that the architect really wanted to have these big, massive columns look like a solid column all the way down. So typically when you get to an expansion joint in a building, you have double columns, and that's what you see above. You can see there's 2 columns that are supporting the structure on each side of that expansion joint. So these are basically, for all intents and purposes, 2 separate buildings. But because they wanted to have the solid column look, we actually have a column that is now straddling our expansion joint, which we can't really have each side of this expansion joint hard tied to each other. So we actually had to design slide bearing connections that these transfer girders would sit on, so that the left side, area C, that building could shrink and grow as the temperature changes, and it wouldn't start to tug on the other side of the building. So it has like a little slip connection in it. And so that's something you'll see a lot of times in road bridge construction, is you'll have these slide bearing connections. That's a very typical connection type for bridge engineers. For building engineers, it's not so typical. So that was a fun little component to get to look into. Here's a close-up picture of one of those slide bearing connections. So you can see this foam board that's in here. That's just what the contractor used to form up the concrete on either side of this expansion joint to create that separation in the building. And then we have our transfer girder here, and it's sitting on this slide bearing connection. And this slide bearing connection made the design of these transfer girders really challenging because we were no longer able to use the stiffness of the columns below to help out with our girder design. So now instead of having a fixed end connection to design our girder and get some help on the flexural design in this girder, we had to design it as a simple support here. So these girders were probably one of the more challenging design aspects, just because they were the longest span, and I wasn't getting to use the stiffness of the columns below. So here's a look at that street that's going underneath the building, and a good look at the transfer girders before they got covered up. And this photo on the right is what you would see from Washington Street. This is the street that you would turn off of to enter the parking garage. So all the employees turn down Race Street, they go down here, they drive underneath the building, and they turn into the parking garage there on the left. Next, I wanted to talk a little bit about some means and methods, construction stuff, and the shoring that had to be designed in order just to pour our superfloor was actually pretty remarkable. And so as the building structural engineer, LA Feast did not get involved with the design and engineering of this shoring, but I have lots of photos of the shoring because I thought it was really fascinating. It's a pretty structure in and of itself. So like I meant, this is the Race Street transfer girder location. So these are those big 65-foot long transfer girders. So those are also 50 feet in the air. So the shoring engineer had to design these massive supports that went all the way up 50 feet in the air and could basically support all the wet weight of our concrete before it reached its design strength. And this is a look at the shoring that had to be put in place for the superfloor. Again, you have to build this deck 50 feet in the air for all of the formwork people and rebar installers to come in and lay out the rebar so they can pour this deck. It's just this massive forest of shores that had to be built. It's like a massive structure to build another massive structure. I thought it was really impressive. I was climbing up a ladder to get up to the level 4 deck one day, and I looked back and just saw this forest of shores behind me. So I thought it was really cool to take some photos of that area. All right, so I've been mentioning a lot these blade columns. This is another term that got coined in our office to describe these massive columns that are 60 feet on center. And so these are large rectangular columns that 32-inch wide by 96 inches deep. They have 34 number 11s, which sounds like a lot of rebar, but it's actually only 1.7%. And for those of you that are structural engineers, you know that for most building columns, you'll get up in the 2 to 3% range. So it's not a ton of reinforcing, but it is. These are really big columns, 7 KSI concrete. These columns actually could have been a little bit smaller. I think they could have been around 32 by 72 inches deep, so about 6 feet deep. But the architect actually wanted these columns to look intentionally massive. So they were looking for this very robust and massive appearance when you come up to the building. So they wanted the columns to be bigger than we actually needed for design. And so I thought that was kind of a funny conversation to have with an architect. Usually they're over there pounding the table asking you to make the columns smaller, and here we are, and they're asking us to make our columns bigger. So that was a very unique conversation to have, and that doesn't happen all the time. The shoring that had to be built for these blade columns was also very impressive. So again, LA Feast, structural engineer, we did not get involved with this design. This is means and methods of construction. It's up to the general contractor to delegate out this design, but it was really remarkable to see all of this formwork in place. And then they have these massive struts going back that are anchored back to the ground, just so that they can pour these massive blade columns. Because as you can imagine, as they start to pour concrete in here, all that hydrostatic pressure that starts building up with the wet concrete can get pretty big. So they had some just really impressive engineering work on this formwork just to make sure that the forms didn't blow out the sides as they started to pour these columns. And they were not able to do, much to the chagrin of the architect, they were not able to pour these columns in one pour. So if you look closely, you can actually see a construction joint here where there was 2 separate concrete pours. So they fought hard to get that in one pour, but it just was not going to happen. So architect had to live with some construction joints or some cold joints there in their columns. Here's a couple photos looking at those blade columns when they're complete. They have yet, in these photos, they have yet to put up the formwork and shoring for the superfloor, but you get a good feel for the perspective, how massive these columns are. There's some workers below and you just see how big these are. And then it kind of looks silly when you see these little 24-inch diameter column cages sitting on top, but those are the columns that are going up to the roof level. All right, topping out party. This is the best day for a structural engineer when the building is, for the most part, structurally complete. They're going to put up the last structural element on the building. The general contractor throws a big party, invites everyone out. And so this was a steel tube that was going to go up on one of the light wells on the roof, and they paint it white and they let all the consultants and every single person who worked on the project sign it. And so there's my signature on this steel beam that's now up on the top of the roof of this building. This is the engineering team that worked on this project. So there's me on the right. Erin Janacek is standing right next to me. She is the engineer record on this project. She is the one who sealed this building. So she's my mentor and team leader. And I've learned so much from her and really appreciate being able to work on these really cool projects. She's a great engineer, and because she's a great engineer, she gets to work on great projects like this. Standing next to her is Caleb Duncan. He is our president of LA Feast Partners. He's also a fantastic engineer, and he's actually also has an architecture degree. So it's really awesome to have him in meetings with architects, because sometimes he can point out things that the architects weren't even thinking about because he has that architecture mind. And then finally on the left here, this is Shinshi. He's an engineer that's just a year younger than me, so he has a lot of experience as well, and he worked primarily on the garage side of this project, but he was a big help to me going through this whole project. So here's some photos from the topping out party. This is a view again from the Washington Street entrance. This is Race Street going down through the middle of the building, going underneath this transfer girder. At the topping out party, they started to put some of the glass in, and then they had barbecue served on the parking decks, and everyone was sitting under here away from the hot sun. After we had barbecue and ate a bunch of food, we got to go walk through the building and show the architect and some other engineers, give them a tour. So I took lots of photos then. This is a look from the Area C office area, standing on level 5. And so this is one of the light wells in the building. And this was a feature that the architect put in so they could let in a bunch of natural light into this office space. So that in this open office area, even if you're far away from the big windows here all around the perimeter, you could still get some natural light coming into your workspace. There was lots of big openings in our floor slab to let in all of that natural light. So during construction, when you just see the bare structure with all these massive holes and this blue sky above, it was really fascinating to walk around and see just what this flat plate PT slab construction looks like when it's complete. It's really pretty magical because you just have this really thin 8-inch slab profile. Here's a look from area A and B, looking back over to area C and D, which is the more office space and the garage below. I mentioned an expansion joint earlier in the project, or earlier in the presentation. Here's the other expansion joint. This building was so big it had to have 2 expansion joints. So look closely, you can see double columns going all the way down. So this is what a typical expansion joint would look like with a column on each side of that joint. Here's a look at one of the open office areas. Again, just beautiful floor to ceiling windows letting in tons of natural light. For those of you that are familiar with Dallas, if you were looking out these windows, you'd be looking over at Fair Park and the Ferris wheel. More photos from the underside of the superfloor, just really I was trying to soak in as much as possible of the appearance of all these transfer girders and just get an appreciation for the magnitude and scale of these massive blade columns. This is a photo looking from the underside of the superfloor, standing on level 3, looking towards the parking garage. So you can see a group of people standing down here at the entrance to the parking garage. That's the main entrance to the parking garage. And that's where employees now walk out of the parking garage and into this building. And so right here where these 2 toolboxes are, that's actually the main doorway into the building. And then this is the lobby space. And then there's, I think it's 4 elevators, a bank of 4 elevators right here that are kind of wrapped by these shear walls. So that's these big slots you see here. Those are elevator shafts now. This is my favorite photo from the whole job site. You get a look of, beautiful look at downtown Dallas there on the back left. You have Baylor Medical Center there on the right. And then you just have this kind of teeming job site below. And there's always something going on every time I went out there. They're always pouring concrete either on columns or on one of the floor slabs. There's always people laying out rebar and post-tensioning cables. And it was kind of just this this amusement park of construction going on. And this is why I became an engineer, because I love seeing stuff like this in action, and I love going out there and watching my structural designs come to life. Now, in addition to all of these big transfer girders and very complicated slab designs we had, there was also some very small components and details that I got to work on. And in addition to doing all these big things, I really like the little things, and I like getting into the nitty-gritty details, even when it comes to a guardrail base embed. So this is just a typical detail we had around some big floor openings in some of the office space. So the architect had cut some holes in the floor plates so that if you were standing on level 4 or 5, you could look down into some of the office level below, and it just created a really airy open space. So of course, those openings in the floor plate needed to have a guardrail around so that someone doesn't fall down in there. So we had to provide an embed in the corner of our PT slab for the guardrail supplier to come in and weld their guardrail post to. So we came up with this really nice and clean embed that's continuous all around the opening. We designed it so that it could fit around the PT tendon anchorages that were going to be in the two-way slab. We had to have deformed bar anchors in there to tie it all back and really get it secured in the slab. So this was the ideal perfect condition. We're able to get a nice embed installed that's flush with the top of concrete so that you don't have to have a lip, or people aren't tripping over a different elevation as they walk across this slab. But that doesn't always happen in construction. And in this particular case, there was an area where the general contractor was not able to procure this size embed in time. And it was going to take too long to wait for that embed to be fabricated. So they made the decision to pour the slab and figure out a post-installed connection later. Well, that made everything a lot more complicated, because now instead of this embed that is cast into the concrete and has anchorage that's developed back into the concrete, we had to now attach something to the outside of the concrete, and that's a lot more difficult. So I spent, I don't know, it's probably a week of total time spread out over several weeks designing a post-installed anchorage connection that not only satisfied our design loads that are required by code for a guardrail, but also were aesthetically pleasing for the architect. So the architect the whole time was expecting, this nice flush look. The embed would be in the same plane as the top of concrete, and you wouldn't even notice that the embed was there. But now we have to stick something on the outside, and you're going to know that something's there. And when it comes to bolting these plates down, a lot of times you're going to have a bolt head and a nut sticking out of the top of the plate. So that the architect didn't like that either. They didn't want to see bolt heads and nuts, every foot sticking out of their guardrail base. So I had to do some research and find some countersunk anchors. And then I also had to figure out, okay, how am I going to resolve my guardrail forces when someone's pushing or pulling on this guardrail? And I had to design a force couple using a couple different sizes of anchors so that I could get the plates as small as possible and get the anchors dialed in and anchored there so that I knew that I was resolving the forces that I was going to be experiencing from this guardrail. So this was, like I said, about a week of my time spent working on this one detail. But I loved every minute of it. It was a lot of fun researching it, trying to figure out the best solution for the project and the best solution for the architect and the owner. And this is actually a photo I took just about 2 weeks ago. I got to go inside the building, and this is my post-installed guardrail base that I designed. And so you can see they painted it, made it look all nice, but you can't see any bolt heads. You can see that there's a little lip here, as this steel plate is not at the same level as the concrete slab below the carpet. But I think it looks pretty good, all things considered. You probably wouldn't even notice this difference unless you were really looking for it like I was. So now here's the completed building. These are some photos that I took in May of 2020. So I got to walk around the outside of the building and get some shots of it. You remember all the way back to the beginning of this presentation when I showed you that architectural rendering. You can see they got pretty close to the final product here. Here's a look at that pointy corner, again, all wrapped up. And now you can start to see that they've covered up my beautiful transfer girder system. You don't see that waffle slab anymore. You just see this nice flush soffit. So here's a look again from the northwest corner, looking at the underside of that superfloor and just the massive space that was created by these transfer girders. Here's standing underneath the superfloor. This is a space that's going to have tables and chairs for people to just come out, relax, enjoy a lunch break, get some fresh air, but also have protection from rain and the sun beating down on them. Again, more photos of that underside. You see these really tall curtain wall panels here on the right. That's the conference center that I alluded to earlier. So that's a facility. I think they can hold around 200 or 300 people for any big presentations or conferences that Baylor Skyline wants to hold. There's another look at that pointy corner again. Just getting I like this photo because there's a group of people sitting down here and you can get a sense of how massive this space is. And here's some photos that I took just earlier in October, maybe late September, with the tables and chairs out there now. And just all ready for people to come and mingle whenever they can mingle again. And this is a photo standing with my back to the parking garage, looking towards the entrance of the building. So these double doors here on the left are into the conference center. And then just to the right of the edge of this photo is the main entrance into the building. And there's that bank of 4 elevators that I mentioned earlier. Here's another look looking down Race Street now. So this is where the building straddles Race Street. If you look closely, you can see our expansion joint here and the columns, the blade columns that had to straddle that expansion joint. So tucked up in here is our slide bearing connection. This is a look at Race Street transfer girders from the other side. Looking to the west, this is where the employees drive in and then turn left and park in the garage. And here's a really pretty photo that actually was just sent to me last night from a friend of mine who was down in the area, and he snapped this photo and said, "Isn't this your project?" And I said, "Yeah, that is." And it was a beautiful shot of the superfloor all lit up and that open patio space just kind of glowing in the twilight time, that magic hour. And just about 3 weeks ago, this building actually won a design award from AIA Dallas. And so this was it received an honor award from the AIA Dallas Built Awards Committee. And so it was really cool to see that the architects' hard work paid off. They had a vision for this kind of boundary pushing design, and they helped it come to fruition. And I appreciate being a part of that, and it's really cool to see your projects win an award like this. So another thing to be proud about on this project. And finally, I just want to show you all a time-lapse video that was created by the building developer KDC. So they actually got access to a building adjacent to the construction site and were able to put a camera up on the roof of that building, and the camera took a photo every 10 minutes. And they didn't put all whatever million photos every 10 minutes in this time lapse, but they kind of condensed it down. So this is a little 30-second video showing the project from basically the site work being done all the way to completion. So I'll play it now. So they started on the right side first, working on the garage. So you see the tower cranes went up on the right side first, and the columns go up. And then once they got going on those flat plate slabs, it went pretty fast. The site was so big that they were able to pour concrete almost every other day because while they were waiting for one side of the building to cure and set, they could start working on the other end. So they kind of were zigzagging back and forth across this building as they went vertical. And so there's the completed building, basically as it stands now. Let's get that. Okay, so that's the end of my tour for right now. I'm sure some people might have some questions, so feel free to fire away.
Jonathan, great presentation. Just wondering the change in the column spacing and the change in the column size that the architect wanted. Was there any look at or concern about changing the cost of the building?
I mean, I think that they knew all along that they wanted to have these extra wide spanning floor plates on these massive columns. So I think that was kind of built into the project cost all along. They knew that this was going to be a special kind of monumental feature building. So it wasn't like they always had the columns going all the way down to the base. Like the plan was always to remove every other column. So yeah, it definitely would have been a cheaper structure if we had all those columns going down. But the intent the entire time was to create this open space by transferring out all those columns.
Okay, and one other question on that. Was there a budget for the project, and how did the final numbers come in compared to what the budget was?
Right. So I don't know what the actual final number was. They're actually still, they're touching up things here and there as they work through interiors, even though there's people in the building now. 70 million is kind of the number that was established at the start of this project. I don't know exactly where they landed on that. So,
well, it sure is an impressive project, and you got to be involved with it. It's the kind of things you really love in your career and the good things we can do. And it's something you'll have good memories of and be able to see your hard work in concrete and steel
Yeah,
for years to come.
definitely.
Encourage other questions. You can unmute.
Hey, Brower, did the street that went through the building, I saw some in your pictures beforehand, it was through the building and went all the way. Did you change it to a dead end street?
It was always kind of a dead end street that you would you hit an alley that actually runs on this photo. It was kind of an alley that ran along this diagonal. It was always a dead end because the dart line actually runs just to the right of this. Yeah, it never really went anywhere, but now I guess it goes to the parking garage, and then the fire lane is actually all along this right side of the building here. So in the event of the fire truck needing to get access there, they would drive underneath the building, turn right, and be able to drive basically all around this pointy corner.
Hey, Jonathan, there was a chat in the platform from Andrew. Can you speak about the foundation system and any geotechnical challenges that the team may have had to deal with?
Right, yeah, that's a good question. I didn't really touch on that. So this was a straight shaft drilled pier foundation. I didn't have that in the Revit model. I turned those foundations off to kind of eliminate confusion when we were looking at that. But yeah, so I think they were pretty typical straight shaft drilled piers. Rock was about 25 feet down, and I think we have pretty good rock in Dallas. So I think penetration into the rock was anywhere from 5 feet to 10 feet maybe. There was some unique challenges with the foundation underneath these blade columns. Instead of going with one massive pier for those to sit on, we actually built a cap below the column, and then that cap spanned to two straight shaft piers that were kind of working as a force couple, because in addition to carrying all the gravity loads, we actually use these blade columns as kind of mini shear walls in our lateral model. So there's a little bit of overturning that's happening in these columns. So we had a pier on each end to kind of help create a force couple, socket that foundation in the ground.
How was the facade attached to the side of the building on the top floors?
So it was yeah, there was a glass system that has embeds that are cast into our slab. We don't design those embeds; those are done by the curtain wall supplier. And then the solid panels that you see, those are just cold form metal studs that in this case they actually all rested on. They were all gravity connected to the level 4 slab, and then they bypass level 5, so they're just laterally tied back to level 5. But level 5 wasn't actually carrying any of the vertical load from the cladding, and then the roof level actually overhung the cladding below, so that just had a slip connection and framed into the underside of the roof slab.
Jonathan, I really liked your smooth design for the rail connection, and I didn't really understand why the contractor had to change that. Can you talk about that a little bit?
Yeah. So that was a really unique size angle. I think it was L3 by 2.5. So it's not a typical steel angle size you see, and I think it was really thick too, so that we could help resolve the moment in that angle. So it was kind of a unique size. So that was kind of the first, I don't know if you would call it a problem, but maybe something we could have foreseen earlier on, but it was a weird size. So fabricating that size angle took a little bit longer. And they were able to do it in other parts of the building, but for some reason the steel fabricator got behind and was not able to produce that angle size in time. And so as they approached the pour date for that part of the building, the steel supplier was not able to get that angle out to the site on time. And the general contractor determined that holding back that concrete pour for those little angles was going to be too much of a schedule delay. And so they said, well, we'd rather pay for a post-installed connection later on down the line than have to delay our concrete pour, which is going to delay all future pours. And we're just going to move forward and pour the slab. So that's the kind of sequence that led to that post-installed connection having to be designed.
Hey, Jonathan, do you know what, was this like a design build or was it a CMAR, or what kind of project delivery was used for this? Do you know?
So I guess when it comes to building structural design, I guess that we do a pretty typical setup where it's not design build. Basically, we have a specified amount of time for design. We're a sub-consultant of the architect. So we have specific deadlines we have to hit where we issue construction documents and then construction begins. There was a developer on the project, KDC, that helped manage all of that for Baylor, Scott and White. But I'm sorry, I'm not as well versed in those terms because I know a lot of civil engineers and other sub-disciplines have to deal with those different project deliveries. But when it comes to all the majority of the buildings I've worked on, we get brought into a project by the architect. We design the building, we issue construction documents, construction begins, and then we handle the CA process.
We got another question from the chat box. William Hayes says, were there special accommodations you had to make in the design for any smart building features that were incorporated in the building's operations?
So I don't know if I fully understand the question, but I think we might be talking a little bit about like wayfinding and some technology that was that's in the building now to help people navigate through there. I don't know if William could elaborate a little bit more, but there was interiors architect Corrigan did do a lot of integration of like wayfinding technology. So when you actually go in that building and you go to one of the elevator banks and you're looking for someone in the building, they have a directory, and you can actually pull up a 3D view of the floor plan and you can see if the person's at their desk, because everyone's key card has a little chip in it. And if they're at their desk, it's green because it's this massive floor plate. So you don't want to have to walk all the way across the building to find someone at their desk and they're not there. So I think that was the question, but let me know if that wasn't. Otherwise, we can take some other questions too if anyone has any.
What was the facade used under the waffle slab?
That was just pretty typical soffit. I mean, I don't think it was, probably just some light gauge studs with some chipboard and maybe some EFIS. It wasn't anything fancy. I mean, because it's 50 feet in the air, so you can't really see it that well. So it was just really something to create a clean surface that they could drop some lighting into, so they could project down into that area.
Nice job on the pictures, by the way.
Yeah, thanks.
Hey, Jonathan, this is Lindsay O'Leary. I have a question for you.
Yeah.
Great presentation, by the way.
Thanks.
Did you have any issues with the quality of concrete during construction on this project? We watched a really interesting session earlier today talking about forensic evaluation when there's trouble with things like honeycombing and rebar spacing. I'm curious if you had any challenges during the construction phase.
Yeah, there was actually one of the first pours very early on. They started pouring concrete in like early 2019, like in the springtime. So there's lots of rain here in Dallas. And I think the GC was getting a little behind on schedule, was trying to be aggressive, and was really pushing the limits on the weather and risking pouring concrete when it's about to rain. And there was one pour very early on. They got about halfway through the pour and a big rainstorm came through. And it really messed up a big chunk of slab. And we brought in a couple of specialty consulting engineers to help us out with that and evaluate the slab. And there was a portion of it that actually had to be chipped out and re-poured. So that was one problem. Another, we did have some low concrete breaks. I will say that this specific developer is very particular when it comes to low concrete breaks. So there was a column that came in low that as soon as it came in low, the general contractor knew that the owner rep developer was not going to tolerate it. So they actually just tore that column down and repoured it with good concrete. So there was a couple issues. For the most part, because we had such a great developer in KDC, they demand a lot from their consultants and from their contractors, and so they want to produce a building that they that they bought. Basically, they want what they bought, and so I think that helped kind of stem and kind of hold back some issues that might have lingered on longer. Because I have had to look at columns that have low strength and make sure that they're okay with a lower strength, or go out there and take cores. Those are two issues I can think of off the top of my head. Trying to think. I mean, there's always little things that happen where, yeah, they're pulling off form work, and maybe you didn't get really good concrete consolidation because there was a couple pieces of rebar that got smashed up against each other. So we had a couple areas that we had to come back in and have them chip back concrete, get the rebar fully exposed, and then apply a specialty product to patch those areas. But we didn't have any major issues.
Thanks, Jonathan. I actually have Susan here with me, and she has a comment for you as well.
Cool.
Oh, Jonathan, I just want to tell you, thank you so much. You just did gave us an excellent presentation, and we just so appreciate everything that you do for Texas Section. So I just wanted to share that.
Great. Thanks, Susan. I appreciate it.
I'm glad you shared that, Susan. Lots of good work by Jonathan in getting this presentation together, and it's so impressive.
Thank you, Bob.
It takes a team for sure.
So what are you working on now, Jonathan? Any big one in the works, or?
Yeah, I'm working on a couple of pan joist jobs right now, more corporate office buildings. My team leader, Erin, her specialty is corporate offices, so do a lot of those. Also a couple of small renovation projects where an owner maybe leased out 2 buildings or 2 floors in a building, and they want to cut a hole in the existing structure and have a monumental stair to connect their 2 levels in the building. And so that's been really cool. Kind of a different challenge because on those projects you're working with an interiors architect, and they're very detail oriented, and they want to design a stair that looks very particular. They don't want you to just throw sizes together and let the steel fabricator work it out. So those are cool because I get to basically play steel fabricator and draw almost every single joint in detail on those stairs. So I'm excited to see. Those haven't been built yet, but I'm excited to go out there when they're under construction.
Thank you. Appreciate it.
That's a good question.
Other questions? Comments?
Lots of congratulations and great jobs in the chat window. Outstanding presentation, fantastic project. That's great, very interesting. So getting lots of those. You can go back and read them later.
Cool. Yeah, I always learn to stay away from the chat when you're presenting on Zoom. Just ignore it.
I don't see any more, but they can definitely have a place there to contact you.
Yeah, for sure. If anyone ever wants to reach out, here's my email, my office line.
Sorry, it's Andrew Domke again. Just wanted to note the post-tension aspect of it. You touched quite a bit upon that. Were there any stressing issues, or how did you all approach the required strength gain there? Were there any type of did you all just do extra cores, or did you guys use some some in place gauges to kind of determine strength for temperature change or anything like that?
Yeah, so on a job this big with this much post tensioning in it, you're going to have cables that break when they start to stress them with the stressing jacks. So we definitely had a few cases, yeah, where they broke a tendon during stressing, or I mean, even I think like 2 months ago, there was a situation where there was just someone who was not supposed to be doing what they were doing, drilling into a slab, and they did not scan, and they hit a tendon and it breaks. So yeah, then we go back, we look at there's several things we can do in that case. We can evaluate the design of our slab or beam or whatever it is that has post tensioning in it. We can evaluate its design with that one tendon or however many tendons they broke missing. We can look at the existing or the lab reports when the concrete breaks in that area and say, okay, we designed this with 5 KSI concrete, but in the concrete breaks, we got 7 KSI concrete. So now we can, in our analysis model, we can increase our concrete strength. We can fine tune our loading, maybe if we know exactly what's in that part of the building now. So there's a lot of kind of general assumptions we make at the start of a project that are trying to, blanket cover situations. And then when they break tendons, we can go back and look at that. But there are several times when we just have to tell them that they need to repair the tendon. And that typically involves bringing the PT subcontractor back out, and they have their own system. Like typically if a tendon is broken, the PT subcontractor wants to be the one to fix that. So we typically just say, you need to go contact the PT subcontractor and they will tell you how to fix it, but it has to be fixed.
And knock on wood, I've never had to deal with that issue, but do you know what the repairs are for that, what that involved?
Yeah, so sometimes they have to get in there and they have to chip back concrete, and they have this coupler where they can try to anchor down the tendons that they're chipping out around. Sometimes they're able to go to the end of the tendon and kind of core out the grout pocket, and then they can, since that tendon is broken, the anchorage should be loose, and then they can actually just pull the tendon out of its sheathing. And then I don't know how they do this, to be honest, but supposedly they can then stuff a new tendon into the existing sheathing and just force it back through, and then re-pull it. I've actually never seen that done, but I've told people to do it and they've done it. So
Thanks for that answer.
Yeah. Cool. Well, I guess there's no one else. I can wrap it up, but I really appreciate getting to speak to y'all. Thanks to Bob for setting this up, and I'm glad we could get a technical tour put together for y'all, and hopefully next year can see everyone in person.
Oh, I see a question from Art. I'm sorry. I think you answered it. Hold on. Any concerns with the PT and the tendon? Yeah, triangle area. So yeah, never mind. Were there any concerns with the PT, the tendon, and the triangular area? Yeah.
Oh, yeah, we had to do some special PT layout in that corner just to make sure we're capturing that, because typically with these flat plate slabs, you're looking at orthogonal right angle slab edges. So having that pointy corner, we added some tendons along that diagonal.
He says thanks. Checking the platform.
Well, I know I just got an email survey, and also you can go on there and print out the certificate of attendance and fill in the sessions. And sure, again, want to give my thanks to Jonathan for a great job, very informative and well produced presentation. Thank you, Jonathan.
Yeah, thanks, appreciate it.
Thank you. Yeah, great segue, Bob. Thank you. Yeah, please do fill out that post-conference survey. We do value everyone's feedback. We hope everyone completes it. Should be pretty short for you. 5 minutes is what we're estimating. So please do get that in. And if you have any questions, you know where to find us. There'll also be a attendee newsletter coming out in the next few days with some details about checking the on-demand videos and how to get the PDF of the program and a reminder about that survey. And as always, most of the sessions did have their presentation up in that files tab back on the platform. So if you wanted to check that out, most of them did offer them up for download. We appreciate you. Thank you, Jonathan. Thank you, everyone, for attending and for being here.
Thank you for all your help, Jenny, and the other
course.
ASCE team that's still on.
Yeah, they're here. They're over there. We're all here wrapping up some stuff, having a little celebratory champagne. It's gone now, but yeah.
Have a great weekend. Thank you all.
Thanks, everybody.